Uh, in terms of recording, are we able to have access to those recording, especially the last one that I missed?
Yes.
Yeah,
Morning,
you
Jock.
should have.
Yeah.
Morning.
Sorry, Hudson, you're going to say something there?
Yeah, so Chalk, and this is a question for Chalk as well. So how does Ilias get access to the recordings? Maybe Catherine's got to give him access or share it with him.
Yeah, I was going
Yeah,
to say that.
suppose.
Send an email
Yeah,
through
so-
and we'll work it out. We'll get. But there is a way. You're meant to have access. Everyone who's invited to the session is meant to have access to them. So
Okay.
we'll have a look into it. But if not,
Awesome.
send us an email to remind us.
Sorry, Chuck, were you going to say something then? I spoke over the top of you.
Oh, no, all good. All good.
Okay, yeah, well, that's right. I'll contact Catherine and just ask you to make sure that you've got access to those videos or how to access them. You definitely will have access, and it's just knowing how to go about that. We went through that process in the previous stage, but you probably missed out on that, so we'll just go through that again. Right, let's get cracking. I'll share my screen. So this is the notes that I sent out last week. I don't know whether you've had a chance to look at them, but we'll go through those. This is the part 2 of basically the engineering process during a project. We talked about design last week. Now we're into construction phase. This is not really, doesn't cover absolutely everything. Every job's different and things will happen that are different to the previous job. So it's just a bit of an overview, just to give you some sort of context on how the projects develop. So when the engineering, I'll highlight this so you can see where we're going. When the design phase is complete, drafting of the workshop drawings is in progress and the HVAC equipment is placed on order for delivery in accordance with the construction program. These things don't necessarily happen in sequence, but they should be happening by now. The engineering team have many activities to perform during the construction phase. Quite often, construction is already in progress during the design phase, adding additional pressure to the timing of design activities. I've worked on a project where the builder was building the building and we were still designing, and it was a very big project. So it puts a fair bit of pressure on the team that these things happen. It doesn't always happen the way you'd like it to. And I've mentioned again, ensure that all steps carried out in the process are thoroughly documented and filed in the correct location. And I've added a couple of notes here. Fundamental things, again, filing, timing of your activities. You've got to refer to the programs and make sure you're satisfying all those requirements. Cost and budget, communication with your team and external stakeholders, and work as a team, help each other. A little definition of quality. It's conformance to requirements. So if there's a specification, you need to conform to that. If it's a design and construct, you set your own standard, which has got to be accepted by your clients. And that's the quality that you need to achieve. Okay, electrical schedules. Again, this is not necessarily happening during construction. It's probably happening during the design phase, but it's a natural process that occurs after you've sorted out the equipment. It might be happening at the same time. You'll have, as you finalise equipment, you'll finalise the electrical schedule so the electrician can do his work. Sorry, did someone speak? No. The majority of HVAC equipment will require a power supply and control system. When the equipment schedules are produced, electrical schedules or switchboard MSSB schedules, mechanical services switchboard schedules must be produced by the engineer and provide details for each item, such as the switchboard label or number. There will be a separate schedule for each switchboard. Don't mix it all up, just have a separate schedule for each board so that the equipment supplied by that board is just shown there. You'll show the equipment labels or identification. It'll show power requirements, voltage, amps, phases, starting arrangement, DOL or speed control, and operation in fire mode. I've got a sample I can show you. Can you see that? Okay, so this is a basic electrical schedule. It's got the project name, switchboard number, and over here you list the equipment. So I've just put one here, AHU1, South Zone Air Handling Unit. This is the motor power, how many amps. Oh, something's gone wrong there, sorry. Volts phase there was meant to be 415 volts, 3-phase. I don't know, must have done a calculation there, I don't know. Speed control, VSD in this case. It may be DOL, but very unlikely for an air handling unit to have DOL. And I've put over here power type NE, which if you look at this little table down here, there's non-essential, which is no generator backup. There's essential, which has a generator to back up power, or fire essential with fire rated cable, and lots of other information. So that's an idea of an electrical schedule. And they need to be filled in with all the equipment and issued to the mechanical electrical subcontractor to enable them to design and install the switchboards and the wiring on site. Electrical wiring diagrams will be issued progressively in line with the mechanical services program. So as you issue the schedules to the electricians, they start working on their drawings. They also need to be aware of the program for the project and produce their work in line with the program. The engineer is required to review and approve the drawings internally before submitting to the builder or client for approval. So don't get into a trap of issuing drawings straight on without looking at them, because someone's going to pick up, if there's any errors in the drawings, someone will pick that up, and it's better if it's us, not your client. Okay, so we should be issuing things that we're happy with, that we're satisfied that it's what's required for the project and it works. Excuse me. Just for the benefit of the MEPEC people as well, we also have a checklist. I think you guys are all aware of this. And this, for all the equipment, or the majority of equipment that are used in projects, we have these checklists for when you're checking drawings or switchboard drawings. There's all these items you can look at and just tick them off. Some may not apply, but it just gives you an idea of what you need to look for when you're checking those drawings. Okay, controls. HVAC control systems are required to regulate and monitor the operation of the HVAC equipment. This includes selection, configuration, installation and commissioning of sensors, thermostats, control valves, controllers, alarms, control panels, and lots of other things in the control system. The control system design aims to provide efficient and reliable operation to ensure occupant comfort or process control or energy optimization through scheduling, set point control and feedback loops. Control systems are provided in various types depending on the type of system. So if you have say a DX system, simple DX system, the controls will be supplied by the supplier of the equipment. You may have third-party electronic controls or a DDC BMS for larger projects. The controls subcontractor will produce and issue their proposed control valve schedules. Now, this is if you have, this is a water system, if you've got chilled water and or heating water. The engineers need to produce a schedule of water flows, pressure drops through coils and so on, and issue it to the control company, who then prepare their control valve schedules So that's in response to the preliminary schedules issued by the engineer. The engineer is then required to check and approve the subcontractor schedules to enable procurement to proceed. So this is another point on the road that you can't delay. If you need to check the schedules from the controls people as quickly as you can and give them comments or approval so that they can get on and order the valves, because they may not be ex-stock, they might have to come from overseas, and quite often they do. So it all takes time. Where a DDC or BMS control system is used, it's necessary to produce a points list for each controlled item and a functional description describing how all of the equipment is intended to operate. These documents will be provided by the controls company and issued to stakeholders for review and approval. Having said that, it's a good idea for us to produce a points list or some sort of description, preliminary description. It may just be a description, it doesn't necessarily have to be a points list, but a points list is succinct, it's easy to read, so the controls company understand how you want this to work. So if it's design and construct, that will be up to us to tell them how we want it to work. If it's a documented project, it should be in the specification, but it may not be. Or it might be very vague, so you might have to work out what's required and let the controls, or talk to the controls people and make sure they understand what needs to be done. I've got a points list here, just a sample of the sort of things that you need to fill in. So for standard general points, outside air temperature and humidity, standard air handling unit may have all these points. That's probably not normally the case, but all those things may be there. Some of these points, you might look at it and say, well, you don't really think these are necessary, and every point costs money. When I was, or going back, say, maybe 5 years, a point was averaged out at about $500 per point. So you can see that if some of these points are not really required, you might as well leave them out, because it saves money. It's value engineering. So on. And once again, in the where are we? In the in the equipment checklist, again for our guys, we have a page for reviewing BMS points lists. You can just scroll back here to find it, but no, there it is. So go forward. So again, there's a checklist for points list there for the benefit of our guys to have a look through it when you're checking them. Okay, so a BMS system will include software graphics of the controlled systems. I don't know how much of these you've seen, but this is based on the approved points list and functional description. Now, the graphics enable operators to monitor and change system operating parameters as required when the HVAC systems are in operation. The engineer will be involved in working with the control subcontractor during development of the graphics to ensure that the graphics are correct. Progress review meetings with stakeholders may be required during this development process. Okay, so I'll just show you some graphics and then I'll talk a bit more about that. So they're not very clear, but this is a chiller plant graphic. So this, on the site, this will come up on the operator's screen, or you can look at it remotely. You may have remote access to it, and you can see various numbers and things on here, which tells you the actual operating point. There might be the set point and the actual operating point. And depending on what access is available to you, you can go into a particular point and you can make an adjustment. So if you want to change the distance, you want to take it from 7 down to 6, you can do that on the graphics. So it's a way for operators on site to monitoring and make adjustments if they want to. So in this diagram, over this side, the left side, you've got the cooling towers. The green pipework is the condenser water to the chillers. And on the right-hand side, the blue pipes of the chill water, and it shows the pumps and temperatures of the chill water, and the same thing on the condensed water side. So they're very, very useful. And but they take a bit of time to develop, so the engineers will be involved in the development of these graphics. I've got another one. Again, it's not very clear, but this is an air handling unit. There's a return air fan, a supply air fan, cooling coil, various sensors, dampers, filters, etc. Okay. Fire matrix. We all know about fire matrices. If the NCC requirements for the building include smoke hazard management, then a fire matrix or a cause and effect schedule is prepared simultaneously with the utilities. The fire matrix is required by the mechanical subcontractor and control subcontractor, so that provision is made in the switchboards and control systems for fire mode operation. It's also required by the fire services contractor to ensure that provision is made in the fire indicator panel for the necessary relays, switches and indication lights, as well as wiring to the switchboards. So a very important document, and communication between a few parties is needed there, and make sure the fire services contractor is in the loop. You can talk to them directly, or hopefully you can talk to them directly, and make sure they understand what they need to do. This is quite often can be a gap in the documentation. Who's wiring the fire alarm relays, things like that. So if you can talk to the fire contractor, get that sorted out early, it'll help. I'll just put up a fire matrix. There's a lot of information on these drawings, but this particular job, you can see there's 15 zones here, or 15 floors perhaps, that depending on where the fire is, one of those zones might be in fire alarm mode, all the others are not. So things are happening, the smoke exhaust fan starts, open dampers on the fire affected floor, and so on. Morning, Alan. Okay. We'll keep going. We've got a fair bit to get through here this morning. Workshop drawings produced progressively in accordance with the marked up design. Sorry, I'll highlight that bit. In accordance with the current drafting program. The drawings are coordinated with architectural, structural, other building services drawings with the intention of avoiding clashes on site. That's what we try to achieve, so that we have minimal disruption on site. During the drafting process, regular communication is required between engineering and drafting to ensure that all the necessary details are shown on the drawings and are correct. During this process, the engineer must also ensure that all the necessary controls devices are shown on the drawings. So temperature sensors, pressure sensors, those sorts of things. Make sure all the valves are shown. Prior to completion of the shop drawings, a check print will be provided to the engineer to carry out a thorough review and complete the check print checklist. Now, again, this is something that our guys use. You guys may have something similar. Let me just bring that up. Sorry. Okay. So this is a sort of format that we use. It's got a list of all the things that should be on the drawing. There might be other things that aren't in here that you need to check, but generally that's a fairly comprehensive list of things that need to be checked off. Now, so prior to completion of shop drawings, a check print will be provided to the engineer to carry out a thorough review and complete the checklist. The engineer will mark any changes required to the drawing and return it to drafting for completion. The commissioning team should also review the drawings to indicate if they have any requirements for additional items, such as dampers or valves, etc. So don't leave them out of the loop. It's a very important part of the team. When the drawings are complete, they're checked again and signed off by the engineer and others prior to issue for approval. So they'll go to the project manager. Commissioning should sign them off as well to say that they're happy with everything that's on the drawings. So then they're issued for approval in accordance with the current drafting program to ensure that ductwork, pipework and equipment is manufactured and installed on time. So we talked about a drafting program last week. Well, we've got to aim to have these drawings finished on time so that all these things can be installed in accordance with the building program. When the drawings are approved for construction, so they go into the system, they've got to go through the builder, the architect, other people to be checked off and returned. And usually there's a very tight time frame on that. So you should ensure that you understand what the time frames are. It may be 2 weeks. If the project's moving very fast, they might be able to reduce it to, say, a week, but you won't get it back the next day. So that's got to be factored into the program as well, that just issuing the drawing for construction doesn't mean you can start on site. You've got to wait for it to be approved and come back. And you might have a 2-week delay. Okay, so when the drawings are approved for construction, when they've come back from being checked off by other people, the drawings are issued to the factory, site, and commissioning teams so that they can carry on with their activities. As the shop drawings, equipment schedules, electrical schedules, fire matrix and control details are finalised for construction, copies of the information are provided to the commissioning team so that they can plan their work and allocate resources. One thing that we used to do back a few years ago was produce a commissioning manual. So rather than give the information to the commissioning team in bits and pieces, just put it together as a manual. It's like a bit like a pro forma operation and maintenance manual, but it's the information that they need to carry out their work, and it makes it a lot easier for them. So it would have things like all the equipment schedules, the electrical schedules and drawings, the shop drawings, and description of how the systems are supposed to work, and controls points list, and so on. So they can look through all that and they understand how the project is supposed to work. So now we're well into construction. There'll always be a number of additional tasks to be carried out by the engineering team during construction. So there's some examples here. I'll just quickly run through these. But this is a subset. There's a lot more things going on. So checking quotation, checking quotations and manufacturers' data to ensure that the equipment offered complies with the equipment schedules and project requirements. Sometimes things don't fit on site. So ductwork doesn't fit in the space that it was supposed to. Somebody else has got in first, and so we're in trouble. So we need to get involved and sort out a solution to that problem. Sometimes ductwork is site measured. The system that we used to use, if there were site measures involved, they would have to come back through engineering so that we could check that those site measures weren't going to be detrimental to the operation of the system. So if you put in a nasty transition or a bend or something, that might affect the fan performance. So you need to be aware of that. Hangers and supports, you may be required to design those. The site team might ask you where to put temperature sensors, pressure sensors, etc., in the ductwork or pipework. Quite often with pipework, when that's being prefabricated, you might have to go to the factory and show them where you need the sensors. Some manufacturers issue drawings, often called certified drawings. So for chillers, air handling units, they might issue you a certified drawing to start manufacture. So that then you need to check them off and make sure everything's correct. Because once they've been checked off, they're going into manufacture. This is a crucial element in the project program and needs to be given appropriate priority. So the manufacturer, let's say it's a chiller, and you've told them where you want the pipe connections, which is normally called the handings, which end you want the pipes on, and whatever else you need on the chiller. That will be on their drawings. You need to have a look at those drawings, make sure everything that you've asked for is shown, and then sign it off. If it's not shown, then you need to get back to them and get them to fix their drawings. And electrician and controls company will always have queries to be resolved. They'll ask for your help there. Mechalec drawings, as I said before, they need to be checked and signed off by the engineer prior to issuing for approval. And this will require regular communication with the Mechalec subcontract. So communication, I keep mentioning that, it's important. You've got to talk to these people. They will appreciate you talking to them and trying to sort things out, because they don't always know what you know about the project. You need to tell them. Controls details, including points list and functional descriptions, need to be checked off and signed off by the engineer prior to issuing for approval. Again, communication with the controls people. Site personnel will often seek your assistance during the installation of the work. So they may not be sure of what's got to be done. They'll call you. You might have to go to site and help them resolve that. The regular site visits by the engineer are necessary to ensure the quality of work is satisfactory and all the equipment is installed correctly and in the correct locations. So this sometimes what can happen is if you've got a lot of units that are very similar, it may not be exactly the same. A lot of fan coil units, for instance. This is a good thing to be aware of. You might have 3 different types of fan coil units. They might all look the same, but they've actually got different coils, or they've got different fans, say, or something's different about them. So they need to go in the right place. They need to be carefully labelled. Make sure the labels are on the units so that the site guys can put them in the right spot. If site guys are not that concerned about what they're doing, and this can happen, they might put the wrong unit in the wrong spot, and it's not going to work properly, and it's going to cause a problem somewhere else as well. So, yeah, just something to be aware of. Okay, so the construction's well underway or getting close to completion. Commissioning starts. During the construction phase, commissioning team will be preparing their work by reviewing drawings and preparing schedules for all of the equipment and systems to be commissioned. So when possible, pre-commissioning activities will be carried out to save time later, so they can get on site and start doing things before construction is completed. Pre-commissioning includes activities like pre-setting control valves, or balancing valves, that should be, sorry. So if you've got stat valves, you can preset those if you've done the calculations to work out what the pressure drop is expected to be. And that'll save time when they start balancing the water. Checking the equipment. So this is another check to make sure it's in the right place. They'll be looking at the equipment schedules and checking the equipment nameplate data and making sure that that is the right unit, and also putting that on their sheets. They'll be looking at dampers to make sure they're installed correctly and in the right places, and start preparing their sheets, the record sheets. When installation is complete, commissioning begins. This involves testing, adjusting and balancing the various systems. There may be commissioning before the project is finished construction. I mean, there might be areas that can be handed over or they can work on. As long as they've got power, they can start doing some commissioning. It doesn't have to be the end of construction. The earlier they can start, the better, because they might be running out of time at the end. So they'll be looking at setting temperature differentials, pressure differentials, control sequences, etc. In other words, commissioning involves putting everything into operation, and it's an extremely important phase of the project. It's getting to the end. And it has to demonstrate that all of the design and construction activities have succeeded in achieving the project objectives. So all the design work we've done, all the construction work, comes down to commissioning. How well does it work? Does it work? Let's hope so. During construction, there are often time delays due to unforeseen events, such as bad weather, material shortages, strikes. These things happen. Regardless of any delays, the builder will usually still aim to achieve the completion date agreed in the original construction program. So the pressure's on commissioning. And this happens not all the time, but on larger projects, it's not uncommon. So instead of having, say, 12 weeks to do the commissioning, suddenly they've got 8 or something like that. And builders are not usually very flexible with completion dates. So the engineering team has a role to play in commissioning. The commissioning technicians will often seek clarification and direction on many aspects of the design as they carry out their work. Even though you've given them all this information, you're the one, or the engineering team are the people who've designed, who have their objectives in mind, but it may not be clearly spelled out, or the commissioning guys may not fully understand it. So you need to work with them so they have a clear understanding of what they have to achieve. The engineer will occasionally be required to attend the site and provide guidance or witness commissioning results, or provide some advice on how to rectify an operational issue. So if something's not going according to plan, we need to look at that and work out what we can do. For instance, an example might be they've got a ventilation system running, and they're trying to achieve a certain airflow, and they can't achieve it. So we need to look at the static calculations. You can look at the system. Has it been installed the way it was designed? Has there been a mistake in the fan static calculations? Is there something in the duct that's, or disruption, or something in the duct that's causing a blockage in the airflow? So you may be required to work with the commissioning guys and try and sort this out. If it turns out that the fan static calculations are not correct, or something's been overlooked, then maybe we need to change the fan, or find a way to increase the performance of the fan. Maybe we can speed it up, or change the pitch angle of the blades, and so on. All those sort of things you'll talk about and decide on the best way forward. All of the data collected during commissioning is recorded, reviewed by engineering, and submitted for approval. So normally, once the engineering team's happy with the data, it'll have to go in for approval. If there's a consultant involved, they will look through it and say, yes, they're happy with all those results, or they might want to come and witness something on site, or they might reject it and say, no, you'll have to do it again, and it's not good enough. Hopefully that's not the case, but it shouldn't get to that, because if we've checked it and we're happy with it, make sure you are happy with it. Don't just submit it. Have a look at it. If you're not happy with it, get the commissioning guys to rectify it. So when we've got acceptance of the commissioning results, project is ready to be handed over to the client for their use. Once again, these things don't necessarily happen in this process. Small areas may be handed over progressively if the client wants to start occupying certain areas, but this is a general guide. So practical completion. Normally when commissioning of the HVAC systems is complete and the systems are in operation, the builder will issue a certificate of practical completion, and the HVAC system warranty period will commence. Warranty period is normally 12 months after practical completion. This means that the HVAC systems can be used safely and beneficially for the client, but there may be some minor defects to be rectified. So it's running satisfactorily, but there might be a few things we need to finalise or fix up. So these defects are rectified as soon as possible within the warranty period, which is also called the defects liability period. So during that 12 months warranty, all these defects need to be rectified as soon as possible. So again, at this point of the project, it's necessary crucial really to ensure that all of the relevant project documents are filed in the correct locations. This will assist greatly when future reference to that information is required. So I'll keep going on about that, but filing is really important. So the building's up and running, and it's into warranty. So now we have to issue the operation and maintenance manuals. So you don't start on the O&M manuals at this point of the project. You should be working on those at various times, collecting, as I said last week, collecting information for the manuals as you're working through the project. Don't leave it till the last minute because it's going to take a bit of time to get it all together. And you can write the description of the systems. Anything that can be done for the O&M manuals during construction or even during the design phase is worth doing. And file it in the right spot, and then you can pick it up later. So it's a requirement of all projects that the engineering team produce O&M manuals, operation and maintenance manuals. It's a very important document and must be completed and submitted as soon as possible after practical completion. So we have to finish commissioning the project before we can finish the O&M manuals, because all that commissioning data has to go into the manual. In some cases, final payment for the mechanical services contractor will not be released until the manual is submitted and approved. So I have experienced this where we put in a final claim for payment and they say we're not paying until we get the O&M manuals. So it's very important. The O&M manual provides a description of all the equipment and systems in the project, design criteria, equipment schedules, as installed drawings, mech and elec, commissioning data, controls information, functional description, so on and so on. It's a manual for the whole project. Most contractors have their own format for O&M manuals, just a standard template that you can use, but in some projects, there's a requirement for a project-specific format to be used. This is something that is best to avoid if you can, but sometimes you can't avoid it. They insist on using a separate format, which means you've got to start from scratch, basically. It might be electronic and compiled in a specific manner to match or integrate with manuals from other project parties. I have worked on projects where at the end of a project, the builder wants to put the whole manual together as a book for the whole project, and it's all going to be in the same format and follow a certain numbering system, and it creates a lot of extra work. But you know, if you can just get them to accept your standard format, that saves you a lot of time. In some cases, mainly on large projects, there might be a requirement for the O&M manual to be compiled progressively via a web-based software system. Aconex is one. There are others. I can't think of the name of one that we've used quite a bit, but and someone in the builders team will monitor that, and they'll set milestones. So they'll say, well, your description of systems need to be in by a certain date, and that'll be another program that you've got to comply with as you go through. And it's a good thing, because if you get those things done on time, at the end of the day, when the project is finished, it's easy, it's all done. And that's the aim of doing it that way. Depending on the type and size of the project, there may be a vast amount of information provided in the O&M manual. It's preferable to provide them electronically if you can. Sometimes they want a hard copy. If it's a hard copy, you know, some projects might have several volumes to get all the information together because there's just so much information. Okay, so the manuals are done. Client handover meeting. This doesn't always happen, but sometimes, particularly on more complicated projects or laboratories, hospitals, things like that, they might request a client handover meeting. So when the manuals are, or when the HVAC systems are operating and the manuals have been submitted, there might be a requirement for the engineer, the leading engineer on the project, or the leading commissioning person, or both, to attend a client handover meeting. In this meeting, the engineer or commissioning leader is required to describe the project to a group of people, including the client, and explain how it's operated and maintained. So this, say for instance, I did one of these on a laboratory project for a university. So they had the operators there, they had the engineering team, they were the client basically. The builder would be there. If there's a consultant involved, they would be there. And it's for the contractor to tell the client how the project operates and how it's to be maintained. So at these meetings, the O&M manuals are really useful for providing a guide to the discussions in the meeting. You can work through the manuals. It's got the descriptions, it's got all the operating data, it's got all the controls information. So it's all there. And these operations, for the client can gain an understanding of all the information provided in the manuals. So it's a good meeting to have. And the O&M manuals are a great benefit to those meetings. So back to the defects liability period, as I said earlier, the project's often handed over fully operational, but with some minor defects to be rectified. The defects are rectified as quickly as possible in the defects liability period. The engineering team may be required to assist with advice on rectification of the defects. Some projects, for instance, Green Star, may have a requirement for tuning of the HVAC systems during DLP or the warranty period. You might have to do monthly tuning, so go and check everything, so you make sure everything is operating correctly, make a few tweaks if necessary. And the tuning involves regular checking of the performance of the HVAC systems and adjusting parameters to improve performance and efficiency if you can. The engineering team will be required to assist with advice to the commissioning team on system performance improvements. The regular reporting, particularly in a Green Star project, you have to provide a formal report, usually every 3 months, on the HVAC system tuning activities and results. And again, the engineering team will assist with preparation and submission of the documentation. May not, the commissioning guys may do it, but they might call on you to assist with putting that together and having a look at the results and making sure that it's all okay. So, final completion. This is when the warranty period or the DLP period expires and involvement with the project would normally end. So it's been running for 12 months. Warranties, any bugs have been ironed out, defects have been rectified. If the building owner or operator requires changes after final completion, we may be engaged to assist with the work. We've been involved right through, we'd be an obvious choice, but not always. They might go and get someone else to do it. At this time, it is very helpful to have access to a current and comprehensive O&M manual so that the feasibility of any is kept. So if you want to see if you can 200 litres a second out of a air handling unit or something, or you can look at the data and make an assessment on whether that's possible. The O&M manual will be referred to continuously throughout the life of the project, of the building, and it's therefore a very important part of the whole process. Now, it's amazing how many projects I've been to, even government projects that are less than 12 months old, and they ask you to come in and have a look at and also that we weren't involved in during construction. So we've been asked to come in and see if we can make some changes or review the performance. So the first thing you ask is, well, can I have a look at your O&M manual? Oh, I don't know where they are. And this is true. You know, it's unbelievable, really. But this is what people do. They put them away. They forget where they are, or they lose them. And because we weren't involved in the initial project, we've got no access to it. So it's really important and needs to be stressed. They need to be put in a safe at the bottom, and that goes for the life of the project. It's not, doesn't finish when the project's over. It goes for the life of the building. And I've also said again, it's also helpful to be able to refer to project files. So it's crucial during all the phases of the project to ensure that all information is filed in the correct location. So sorry I keep saying that, but that's really important. So the project's finished now. Everyone's happy, we hope. But it's a good idea to have a project review after completion. So when it's reached final completion, or even earlier, it's recommended that the project team get together and discuss the execution of the project. It's an opportunity to share amongst the team any issues experienced during the whole process and hopefully celebrate the success of the project. Some of the topics that that could be discussed at the meeting include: were there any issues with equipment used on the project? So how did the air handlers perform? Were they okay? Do we have trouble with manufacture, etc.? How were they rectified? Any issues with project team coordination and achieving project milestones? So did we all work well together? Did we make sure that we, as a team, we achieved the milestones in the project? If we didn't, what happened? What was the reason for the delay? Were there any issues with installation and commissioning? How were they rectified? So, for instance, the commissioning team will be there, or at least the commissioning leader will be at this meeting, and might say, well, you know, we found that a lot of dampers weren't installed, so we had to get those done, and things like that. Or were there a lot of site measures that that caused problems with balancing of the systems? Any lessons learned at any stage of the project, and make sure that the lessons learned are documented and discussed with all the relevant people and documented for future reference. The financial performance of the project is obviously important, and so the project manager should tell the team how we performed to budget, and you know, did we achieve the profit margin? Do we improve it? Obviously, as an engineering group, we're always looking to find ways to improve the profit margin in a project, because they're usually quite low. Profit margins are very tight. It's very competitive out there. So if we can improve the profit margin, that's what we're there for. Was the builder or client satisfied with the work, and were good relationships developed? You know, you're going to have your arguments, I guess, with the builder along the way, disagreements, but at the end of the day, we're all trying to get the job done. So if we get the job done satisfactorily, we should finish up in a good relationship. That's what it's all about, and which may lead to future work. So just a final comment here. I'm going back to the end of the design phase, but when the design phase of a project is completed, the engineering involvement is likely to reduce, not necessarily, depends on the project, but and some or all of the engineers involved in the design phase may be able to commence work on another project. So it depends on the size and the type of project. So they might be able to start another project, but this will depend, as I said, size and complexity. Large complex projects may require full-time engineering involvement right through construction and commissioning. So a hospital, for instance, we worked on a very large hospital in Queensland, or 3 very large hospitals, in fact, but one that I was directly involved with on site. We had a team of 10 engineers. And because it was designed by a consultant, but not actually completed, and construction had started before the design drawings were finished. So our role then was to take those incomplete consultant's drawings, turn it into complete design drawings and then construction drawings, and then do the construction. In the meantime, the construction is underway. So there was a lot of pressure there. And that whole team stayed together throughout the whole project, right to the end, because we had to be there to make sure all the details were up to date and check the work on site and so on. Once commissioning starts, you can start to go on to other things, other projects, but up to that point, we were fully involved right through. So that's the end of the notes. Any questions? I got through that a bit quicker than I thought I would. I hope I didn't go too fast, but anyway, you can have a read of it, and hopefully it's helpful. It's about a process, as I've said. Everything we do is a process. If you can follow the process, it makes your life a lot easier. Things will get you off track at times. Emergencies will occur, but having some sort of a guide will get you back on track. And this is where programs become very helpful. Working out what you need to achieve time-wise, and sticking to that. All right. Well, next week we're talking about chillers, and particularly chiller controls, and the different types of chilled water systems that you'll come across. So we'll talk about primary, secondary, variable primary, chillers in series, these different sorts of things that you'll come across. So it's just good to be aware of that, so that if a project comes up with chillers, you can have a look at the different systems, or if you see a project, you'll understand what sort of system it is, and you might look at doing it differently. If someone designs a system with a, say, primary, secondary system, you might look at it and say, well, I think we could do it as a variable primary, and there are some benefits. So we'll talk about those sorts of things. But if there's no questions, I'll let you get back to it, and we'll see you next week. Thanks for your attendance. And Hudson, could you say that again, please?